interval. And so we'll write these descriptions, but first let's just start with example 3 so you can understand a little bit of basis for what we're doing. So put brackets around 0 and 6. It's a closed interval, so we're actually going to test the endpoints. What shape does this make when we graph it? Makes a parabola. And so what we're going to do is we're wondering what is the largest value and the smallest value over that given interval. And the first thing that we're going to do is we're going to check the endpoints. We're going to see what f of 0 is and what f of 6 is. If you plug in 0, what do you get? 3. If we plug in 6, we get 36 minus 24 is 12, plus 3 is 15. So does that mean that 3 has to be the smallest value over that entire interval? No. Why not? Yeah, the graph could behave differently than what you see, okay, from these values. So what we're going to do is we're going to find our critical points. And the critical points occur either where the derivative does not exist or where the derivative is equal to 0. What is the derivative of this function? So 0 equals 2x minus 4, so x is equal to 2. So I find f of 2 as well. And that will tell me some of the behavior of this function. If I plug in 2, I get 4 minus 8 is negative 4, plus 3 is negative 1. So what's interesting is now I can generate a little bit of a sketch. I'm going to count each of these as 5. So f of 0 is 3. I'll plot that. F of 6 is 15. And then f of 2 is negative 1. So we did uncover that there is some behavior here that we didn't recognize unless we took the derivative. And so now we can confidently state what our absolute max is and our absolute min. What is our absolute maximum? 15. And what is our absolute minimum? Negative 1. Negative 1 is also a local minimum. So the process for trying to identify the absolute max and minimum over a closed interval is, number one, make sure you check the endpoints. So we'll plug in the endpoints to see what kind of value we get. You can't have a local max or a local min at an endpoint, but you can have an absolute max or absolute min. Did your professor use the term absolute or global? Do you know? Or absolute. And as far as a local min or relative min, both? Okay. So after we find the endpoints, we are going to then find the critical points. And that's where you set it equal to 0 and where you then look for where it wouldn't exist. And then you're going to plug those critical points back in. Okay? And then you're going to compare the numbers. So let's try one that uses our calculator. So if they gave this type of problem to you on the AP exam, my guess is that this would be a calculator type problem. They want to be able to find the absolute max and absolute min over the interval -6 to 3 of that function. So first of all, I plug the function in my calculator, and then where should I go? Yeah, I go to table in this situation, and I would type in -6. Just get rid of all these. And I'd type in +3. So we have f of -6 is -104, and f of 3 is -23. Well, that tells me where the endpoints are, but is it possible that this function has a value that's positive? Yeah, we don't really know, though, until we, find the derivative. So what's the derivative? Yep, 6x squared. Good. I'll set that equal to 0. Can I factor it? Let's Factor out of 6. We x squared plus x minus 6. So we have 6 times x minus 2 times x plus 3. So my critical points are at x equals -3 and 2. So I'm going to plug those values back in. I have f of -3 is 85, and I have f of 2 is -40. And I know that you don't have to make the graph to understand. I just want you to get the visual what's going on. Say each of those is 20. So I have -6, -104. Kill any calculators on the tests? Okay. F of -3 is 85. Two is -40. Then f of 3 is -23. So it looks like the graph looks something like that. So what would you say is the absolute max? 85. And what's the absolute min? -104. So again, you test the endpoints, and then you find the critical points by setting equal to 0 after you take the derivative. That's it. Yep. I used to try to take Friday's lesson and then today's lesson and do it in one day, and we just always ran out of time. So I just divide up into 2. You guys are going to have enough time to be able to get the majority of your assignment done in class. You have all the time after we get back from lunch to work. Nice quick day. Trust me, tomorrow and Friday, or tomorrow and Wednesday will be a little bit longer.